Hi, this is Kara Tierney from Monroe Community College, and in this video we're going to talk about enthalpy of reaction, and specifically a type of enthalpy of reaction called enthalpy of formation. So what is enthalpy of reaction? Sometimes it is referred to as a heat of reaction. If you remember, heat is Q. For our purposes in this class, we can think of enthalpy of reaction, which is delta H of reaction, as being exactly the same as Q of reaction. For our purposes, they're the same thing. So we've talked about that a little bit in class, and today in this video, I want to talk about a specific type of reaction, which is a formation reaction, because the enthalpy of formation is a very useful property of substances that we're going to see in the next video can be used to find enthalpy of all sorts of different reactions. So a formation reaction is when you have 1 mole of a substance being produced from its elements in their standard state. So the standard enthalpy of formation is the amount of energy that results when that 1 mole of substance is produced from its elements in their standard states. So the first thing we're going to do is we're going to review how to write an equation that would represent a formation reaction. So how we write a chemical equation to describe the standard formation of a compound. So number 1, the substance that we're talking about is being formed, so it is a product, and it is the only product of your reaction. 2, the coefficient of that substance must be 1 because we're only forming 1 mole of that substance. This means that this may require you to use fractional coefficients for the reactants. And that's why we talked about using fractional coefficients in an earlier chapter. And the third thing that you need to consider is that the reactants are all elements that are found in the compound in their elemental form. And this is where you have to remember which elements are diatomic, because all of the diatomic elements are going to be in diatomic elemental form when they are in formation reactions. So let's do one together. We're going to do the standard formation of ammonia, NH3 gas. So the first thing we're going to do is we're going to draw our chemical equation arrow, and NH3 gas is going to be our product. We're going to leave it with a coefficient of 1. And so now what we're going to do is we're going to pick apart this compound. We're going to identify the elements that make up the compound and what type of form they have when they are elemental. So our first element in NH3 is N, nitrogen. We know that nitrogen is diatomic, so we're going to have N2 gas as one of our reactants. The other element in this compound is hydrogen, which is also diatomic, so it's going to be H2 gas. And now we need to balance our equation. When we do that, we need to take in mind that our coefficient for the product has to remain as 1. So what we're going to do is only add coefficients to those reactants. So let's take our first one, N. We know that we have 2 N's on the left side and only 1 on the right side. So we need to write a fractional coefficient. And what we're going to do is we're going to, for the numerator, write how many we want. So we want 1. And we're going to divide it by how many it comes in packages of. That's 2. And we can check our answer because 1/2 times 2 is indeed 1. We're going to do the same thing for our hydrogen. We know that we need 3 of them to balance out with the right side of the reaction. And so we're going to write a fractional coefficient for hydrogen. We want 3 of them, but they come in packages of 2. So we divide 3 by 2, and 3/2 times 2 is equal to 3. So this is our reaction to describe the standard formation of NH3 gas. I want you to give a compound a try right now. I want you to write the standard formation equation for potassium chlorate that's solid. Take a moment right now. I want you to pause it, try writing this equation, and then press play when you're ready to compare your answer. So for our equation, we're going to have potassium chlorate, solid potassium chlorate, as our only product. Our elements that make up this compound are potassium, and all of our elements, when they are in standard form, unless they're diatomic, mostly they're solid. So potassium's solid. Chlorine we know is diatomic, so all of our diatomic elements are gaseous, except for iodine, which is a solid, and bromine, which is a liquid. And actually, bromine and mercury are the only two elements that are liquid in standard state. Our other element is oxygen, which is also diatomic. And now we balance our equation. Potassium is balanced. Chlorine needs a coefficient of 1/2, and oxygen needs a coefficient of 3/2. And this is our correct equation. So now that we know how to write the formation equation for a substance, this is going to help us out in some future lessons. I will see you in the next video, which will be applying this.